Okay, hi again, everyone. I guess at this point we should get going. Monica, about your request, Andy's suggestion may be what you're looking for. Um, if that's enough for you, great. Or if you would like me to just show you again, just sort of go from being on my machine to logging in, doing something and logging out, I can do that. So yeah, just let us know if Andy's link is enough for you, or if you do want to see the steps in sequence, I guess. But for the time being, uh, let's get going. I can see people are joining the session now. Great. Okay, so this is the last session where we sort of have structured material, um, which is how to move your use of ARCHER2 forwards. So hopefully this course has been helpful in just getting you going with understanding what the system is, how to log in, how to develop and build code, and how to then run the applications as jobs on the compute nodes. Here you can see how you can take your use of it further uh, and expand what you're able to do. So I guess we've mentioned it a couple of times, but the service desk is always there if you need help. You might be running into issues anywhere from having trouble logging in to building your code to running jobs. You might be finding that you're getting errors you aren't expecting during the tasks you're trying to do and you aren't sure what they mean. It could be that you think everything's perfect and then you come to do an sbatch run.slurm and it gives you some strange slurm error message and you aren't sure what it means. Anything which you aren't sure about and can't find any sort of obvious solution to, please get in touch with us at the service desk. The email is given here and we will be very happy to help. The CSE service also offers a callback. So if you would prefer to talk with someone, what you can do is you can send in an email and request a callback, and we have people on duty. There's always someone available to do this who can schedule a call with you over Teams or whichever video conferencing software you prefer, and you can have a quick chat with them to hopefully give them a better idea of what the issue is. They can hopefully offer you advice then, which may sort the issue out for you, or they can then go away and get looking into it more in depth. The documentation we looked at briefly yesterday is linked there. You can get to it from the ARCHER2 website. Andy's just put some links in the chat there to the quick start guide, which you may also find useful. This has two sections. One for package users, which are people who aren't really expecting to build code of their own, to build software. These are people who are just going to be logging in, writing scripts, putting initial conditions, input data in place, and then just sending a job off to the compute nodes, which is going to run probably the CSE installed software like GROMACS or VASP or the like, software which they don't have to build and install themselves. But there's also a quick start guide for people like you, people who are expecting to be developing software, and it just has provides basic overviews of the points we've really been talking about yesterday and today, the programming environments, the file systems, how to debug and compile, at least starting points on those topics. Then there's the user and best practice guide, which goes into a lot more detail. There are many sections here which break everything down further. There are sections on the hardware connecting in the I/O and file systems, running with containers if you're interested in using Singularity to run containers, Python, data analysis, and much more. as well as pages on each of those pieces of CSC installed software, like GROMACS and VASP I mentioned just now. We describe how to use them, which modules you'll want, provide example scripts that you can start with when running jobs with them, as well as some documentation on using SAFE. Training, well, we're in a training course at the moment. After this one, you might be interested in courses on using various software packages efficiently. We run these on different pieces of those pre-installed software. We run software and data carpentry workshops, which help you improve your software and data analysis skills. They'll be run very similar to this because we're following the carpentry's methodology for this course. I mentioned containers just now. We do run a course on using containers. If this is something you aren't too familiar with, this is a nice introduction on what containers are, how they work, and how you can use them on ARCHER2. And you can just head through to the ARCHER2 training pages. Let's just open that now. Take a look. Oops, let me bring up my toolbar. We can see what's upcoming. So we have a course on message passing programming with MPI coming up. These are 3 self-service courses. I believe we're actually moving into the next period of training just now. So they aren't up here yet, but if I check quickly, I can see we've got yes, we've got a course. We have an in-person, a course like this done over call for MPI coming up. Use of lamps, use of GROMACS, parallel Python for data analysis. So there are a lot of courses coming up. I imagine these will be on here soon to open registration. So if you do want to move your skills forward, these are fantastic ways to learn something new, test them out, do some examples, have people there to help you with them if you run into issues, and do all of this on ARCHER2. In terms of getting access to ARCHER2 for your research, again, I think a lot of you already have access or will be getting access soon through projects that you're involved in. But as time goes on, you may want to look into getting access for yourself in some way. The ARCHER2 driving test is now open. This opened, I think, just a couple of weeks ago now. This is a short course. It doesn't take very long to do. You can just do it yourself, and then a quiz to take, which just makes sure that people taking it know what they're doing when they get logged on. It just takes you through the very basics of logging in, loading modules, running jobs. There are, again, different ones for software package users and for developers also. So the content changes slightly between those 2 driving tests. And once you complete it, UK-based researchers get a small amount of time, so you can log on, build your code, maybe use that time to do benchmarking and the like, which can be helpful because you may then want to pursue another another access route which grants more compute time for you to use. So you can get access through scientific consortia from EPCC and NERC, which may be the simplest if your research is under one of the consortia remits. There are pump priming applications, which can help you, again, get scaling information if you need that. And ARCHER2 and research grants can also award time. We have access to HPC calls, which grant larger amounts of resources again. So for these 2 in particular, you will be asked when you go through these to provide a technical assessment, which is just to make sure that the work being proposed is actually appropriate for ARCHER2. And part of that will be a request to show that the jobs you want to run scale well to the point that you're intending on ARCHER2. So things like getting time from the driving test or from a pump priming application can let you give you access just to do that small amount of initial work, just to show that your code works well and is appropriate for ARCHER2, before then moving on to a larger application. And again, the link here, if you follow that through, will take you through to the ARCHER2 access page, which has more information on all of these various routes and how you can apply for them. Another project which you may be interested in is the ECSC program. This is a little different. So these calls open, and I'm not sure, I can't remember when the next one is open for. Let me just double check. These give you time. So these actually pay for software development, essentially, on code that you are working on. It may be that you have a code which doesn't scale well, or you want to add functionality to it, or the like, and this pays for time for a software developer. This can be you or someone in your research group or someone at EPCC to work on this code and give it that extra improvement or functionality. Let me just quickly check to see. So the 6th call is closed. I can't see when the 7th call is, but this may still be of interest to you. It's a fairly in-depth application. So again, you'll be asked to show what your code is about, provide technical information, what requirements it has, show, for example, how well it scales at the moment, what's the point of the functionality you want to improve. And yes, and then you'll, as part of it, you'll request time for software engineers, either you or other people, to do this work on your code. Finally, it's of course very helpful, again, similar to the points made in the last session, it's helpful for use of ARCHER2 to be made known, to keep support for the service and maybe any future successors up within the groups of people who matter. I'll say the people from whom the money flows. So any outputs, papers, or the like, if you have an acknowledgement section at the end, it'd be fantastic if you could just mention it with this phrase, so that anyone who reads it, sees it, will know that ARCHER2 was used to get the data, to do the work in that publication. Okay. So at that point, that's a very short session, isn't it? We'll move on to the bootstrapping session. So this is what I was talking about earlier. We've got a long time in this session. We've got essentially all the rest of the day now, just here. This is a very flexible, open-ended session. If you feel that you don't want to get anything else from this course, you can of course leave at this point. If you do have any codes that you want to try building, or you want to try just running jobs now on the reservation we have, please stick around. I'm sure you would get a lot of use from this session. So we can talk with you now. You can ask questions you might have, either about your own workflow, about what you want to do with ARCHER2, about the codes you want to use, how to use them. You can ask any questions you like about this. You can, and of course, if you want to actually try out your code, this is a great opportunity to just spend a couple of hours, copy your code onto your account, try building it, see what happens, ask for help if you run into issues, or ask for advice. Or if you just want to mess around, we have an input file for GROMACS, which you can download from the course website. You can get that onto the system, into your account, into your work directory. Try writing a job script for it to send it off. And what you can then do is try doing things like varying the number of nodes. And in the output, you'll see what the performance of that run was. It gives it to you in nanoseconds per day. So if your simulation can get through more nanoseconds per day, so that's nanoseconds of simulation time per real day running, if you like. You can try benchmarking this. You can vary the number of nodes, the number of tasks, vary the number of tasks per node. Try using threads. So go and do a hybrid run with OpenMP as well as MPI. You can do the last step here, turn on symmetric multi-threading, see what happens there if you start running with multiple threads on each core. That could be interesting. So if you'd like any of these, try any of these, please have a go. Also, as I said, I'll use this as an opportunity just now to demonstrate, well, actually, I mean, I could do both of them at once. So Angela's was asking about showing how to connect to a running job with GDB for HPC. So I'll show that now, and I may as well combine it, just if it's helpful for you, Monica, just to show you how to do this from a starting point, from logging in through to the, and then going through to the end. So so I'll just show you that now, and please ask any questions if you aren't sure about any of this. Oh, there's a new message. Where is it? Monica says, sounds great. Okay, fantastic. So I'm logged in at the moment, so I'll just use logout. Exit also works. Maybe something which would be helpful for you all, something which is handy, I think. Do any of you, are any of you using Linux or Mac OS? Because there's something, because you're probably all logging in doing things like, Mac OS, any Linux users there? Okay, so Mac OS, Linux. Okay, so are you all logging in doing, and Windows and Mobile Xterm? Okay, so Mobile Xterm is possibly simpler. In some ways, I think it's a little more complex to set up, but it saves your login credentials, so you just provide your passphrase and password. So I log in doing this. So I just do SSH, and then I'll be what is it, TA051, and that sort of knows what to do. It knows to log me in with my username at login.archer2.ac.uk. What you can do is, let's see, you can write a config file. Have any of you written an SSH config file to do this, or are you just logging in directly doing SSH WLTA 051 at login.archer2? I showed this at the last course I ran of this, and I think the people appreciated the little bit of simplicity this added. Let me quickly set this up and I can show you. Okay, yeah, so I'll show you how to do this. This is, I think, it just makes accessing the system a little faster. If you're having to log in 10 times a day, it's much quicker to do something with fewer key strokes. I'll just show you mine, and those of you on Linux and Mac OS can just do the exact same thing. Let me just quickly do this. And if I'll just set this up to show you. Where is it? There we go. Sorry, just a second. Yeah, I think so. That's to do with the locale. I think I don't think it's necessarily something you need to worry about. It probably means that the locale you have on your local machine isn't there on ARCHER2. Yeah, Andy's just said nothing. Andy said nothing to worry about, and I trust him on that. Okay. So this is something you might be doing, and you might be doing an I, and then you'll be saying to it, use this SSH key, and it might be called ID, RSA, TA. It might be called anything. A quicker way to just set up a login is to create a config file. So if I can just show you. I have inside SSH a file called config. So those of you on Linux and Mac OS have this .ssh directory in your home directory. It's hidden normally because it begins with a dot, but it's there. And if you edit this file or create it if it doesn't exist, you can just add a few lines like this. We don't need that actually. You can just create a few lines like this. I hope you can see that with the colors. But it starts off host, and then you just give it a name. So I'm just calling this TA051. That's the course, but you can call it whatever works for you. And then you just give it a host name, login.archer2.ac.uk, and user. And what this means is that I can now. Okay, great. Thanks, Monica. Good to know it's visible. Is with that, I can now just do SSH TA051. And when I do that, it checks the config file, sees that I've got a host line called TA051, and knows that what it's got to do is it's got to log in to login.archer2.ac.uk with username WLTA051. So ultimately, it's doing the same thing as SSH WLTA051 at login.archer2.ac.uk, except this is, well, it's much faster to do this, isn't it? And you can also add a line to it. I don't do this because I use the SSH agent, which I told you about yesterday. And you can do, well, for me, it's user. Is it user? I think it's user. I'm William /.ssh, and then you would just give it, ID, RSA, whatever the name of your private key is, and it will then know to use that private key when logging in. So that's something you may want to do. I'll copy this, and I'll let me put it in the Etherpad. It keeps on disconnecting me, doesn't it? I'll pop it in here just in case you want to set up something similar. .ssh config file, if it doesn't exist yet, and enter and that's formatted it badly because of Vim. Let me just do this. I'll just change that to a user. Oh, sure. Let me put the link in for you, Monica. There you go. This should be linked to, as I say, we will provide a link to this on the course page once we strip out all of the personal information from it. So if you want to come back here in the future, oops, and then after that, you can just use something much simpler to log in. And as I say, you can create as many hosts as you like. If you log into other machines, you can do the same thing. You just change this name here, TA051. You know, you might have this, you might call it ARCHER2, in which case you would then do SSH ARCHER2. You can do that for as many, and it just makes getting logged in that tiny bit easier, which is, you know, always nice, isn't it? Okay, so let's, bearing in mind that this is how I'm logging in. So to log in, I'm just going to do TA0 SSH TA051. I went through the SSH agent step yesterday. I did SSH add, and then gave it the path to my private key and told it what my passphrase was, so it knows what that is. Mike, you're on mobile extern, so you kind of don't need to worry about this. You sort of tell mobile extern where to find the key anyway, I guess, don't you? So this is sort of done implicitly. But for me, it knows about my key. I've set up my .ssh/config file to include that bit of information there. So it now knows that when I tell it SSH TA051, it knows to log me in as WLTA051 at login.archer2.ac.uk. And then I'll just give it my login, my machine account password, which I will grab from my password manager. If I can find my passwords, because as I say, I have too many accounts and I can't keep track of them. And that's me logged in. Okay, so here we are, we're logged in. We've done nothing at all, but our goal is to run something, something which we know is going to crash, or, well, is going to hang. Attach to it with GDB for HPC to find out what's happening, and then we'll log out. So we log in, we're in our home directory because it tells us our path here at the bottom, and it's the little tilde, which means we're in our home directory. We can confirm that by doing pwd, and we see, yep, we're in /home/ the project code TA051. We aren't in a subgroup, we're just in the main project, so we're in /TA051 again, and then there's my username. So that's me in my home directory. And we're going to run this task as a job. So we're going to go to our work directory, which has a nearly identical path. It's just work at the beginning rather than home. So it's all of this, but it just begins with /work instead. And there we are, I'm now in my work directory. And of course, remember, we want to do that because it's the work file systems which are available on the compute node. The home file systems aren't mounted, so there's no point in trying to build and run our code there. We would just get some errors telling us that it can't be found, or something similar to that. Okay, So I thought we may as well just use the same debugging code we used, because that's hung. Remember, it gets to the point where there's the MPI communication, except the tags are wrong and they're looking to receive from the wrong task. So we know that that the debugging exercise code will hang when it reaches that MPI communication. So what we're going to do is we're going to grab that code, build it, then I'll write a new job script to show you that. I'll send it off to the compute nodes, and we're expecting it will get a little way in and then hang and do nothing. At that point, while the job's still running, but it's hung, I will try to attach to it with GDB for HPC, and we'll do a little digging around and see if we can find out exactly where it's hanging. I mean, we already know the answer, but let's pretend that we don't. So I've moved into my work directory. I'm going to create a new directory now, and I'll call it debugging attach. Say that's a decent enough name for just now, and I'll cd into debugging attach. That's empty because we've just created it. So I'll get the same bit of code that we used before. I'll download that again. There it is. So I'll use Wget to download that C file from the internet. Press enter. That's downloaded from the internet. And if I ls, there is the code. Step one is to build it. So it's very simple. It's just a single piece of source code. We don't need to run make or CMake or anything. So we want to compile it with the C compiler wrapper, which is lowercase cc -g to add the debugging symbols to the executable, and I'm going to name the executable GDB for HPC exercise, just the same as we did earlier. So at the moment, I've not done anything new, and if I ls again, we'll now see there's the executable. Yep. So yep, I'm using the default modules which you get when you log in. So if I do module list, we'll see what those modules are. So these are the ones which you get when you log in. I haven't done anything to change what those modules are. So for a normal account that you get, this is what you'll get when you log in. Some people change their bash RC and the like to change their default modules, but I personally don't do that because I never know which modules I'm going to need. So I just log in myself and then start setting up what I'll need for that session. So these are the default modules, the ones that all of you will have when you log in and do module list. The important thing here, as regards our building of the code, is that by default, remember from yesterday, we get progenv cray and CCE loaded. So that means that at the moment, whenever we use lowercase cc, like we just did now, to build our code, we're using the cray compiler. If we want, we can module swap out progenv cray for progenv GNU. That's now changed the it's reloaded the cray mpitch module because that's now changing to use the GCC build. We don't need to worry about that. Remember, the progenv takes care of everything for us. So to switch from the cray compilers to GCC, you just do module swap progenv cray to progenv GNU, and the module system will take care of everything in the background for us. And to then build it with GCC, we use the exact same command. We don't need to change anything, just the module which we have loaded. and that will do the same. So that's now a GCC build. Let's just carry on what we were doing originally. So I'll go back to the module swap, and now I'll change back to Cray. So I'm back again now to the modules that we would have if we just logged in and done nothing at all. So we're back with progenv Cray, and we're back with CCE loaded. And if I build it once more using the exact same command, that's now been built with the Cray compiler instead. So in terms of building your code, it's really just a matter, well, I say really, of course, it's going to be a bit more complicated than this. It's a matter of logging in, changing to the programming environment that you want to use. So if you want to use Cray, you can just leave it as progenv Cray. If you want to use GCC, swap it out for progenv GNU. If you want to use the AMD compilers, you again swap out the progenv. Then if the thing that you're building needs any other modules, you would then start doing module avail and module spider to find those modules that you need. If it turns out that it's a module which you can't load immediately because you need to load something else first. Remember, module spider will tell you how to do that. We saw that yesterday. You would then just load the modules which you need in order. You possibly have environment variables you will need to set as well. This depends so much on what it is that you're trying to build that I can't really give any generic advice other than this is the stage where you prepare the environment. If you do have anything you would like to try building, these next 2 hours are your chance to have a go, and we can give you help if you need it. Just for now, I'll carry on with this example. Oh, Mike says, if my code has a dependency in a library that's not installed in ARCHER2, am I able to install it myself and use it to build my code? Yes, absolutely, yes. I mean, this is really no different from you just building an executable. If you need anything which isn't available centrally, you can absolutely get the source code yourself, build it. You can install it in your own work directories. Remember, that's important. You need to install them in your work directories because then at runtime, the libraries wouldn't be available if you put them on your home directories. So you would download the source, build it, and install it to your work directories. Yes, but you can't do sudo apt-get sudo zipper. Yes, so you can't install things through the operating system's package manager. So it will be a matter of downloading tar.gzs of source code or git cloning from GitHub or the like, and then getting to building. Yeah, pip installed. So for Python packages or things which you can get through pip, you can tell it to install in a user location instead. I think you need to set an environment variable first to make sure it installs in work and not in home. That's in the documentation, isn't it? Where is it? Yes, you need to set, I'll just copy it from the documentation. You need to set that first, and then pip knows that you can install into work rather than into home. And indeed, containers are an option as well, and they work really well, actually. Okay, great. Okay, and let's carry on with this example. Okay, so we're back now in the default, I'll call it, environment, just the set of modules which we'd have during when we first log in, and we can build our program like that. So so now let's just write a job script to run it. What will I call it? I'll call it run example. I'll just call it run.slurm. Okay. Now let's try and piece together the parts from this. So we yesterday saw how to write scripts. So let's just it says, should we download our code we'd like to compile onto a course login account work directory, or the one we normally use for our project? So if you want to do it on the course page, you're welcome to, and that means if you can build it, you'll be able to run on the reservation we have until 4 o'clock this afternoon. If you would prefer to do it in your own directories, that means you'll be able to use it for longer. Of course, if you do it on the project directories and manage to build it, you'll then need to remember. So if you do it on the course project and then build it, you'll then need to remember how to build it to do it again on your normal project. So maybe in the long run, it might be easier to try on your normal project. Okay. Where was I? So okay, great. Okay. So we'll base our job script over this one. I always have to look them up because I always forget some option from there. So first of all, we'll start off with the shebang that tells it that it's to run through bash. Then we've got all our sbatch options that we need to add so that Slurm actually knows how we want to run the job. We'll just do this the exact same way that we did in the example. So we'll aim to run on a single node only. So nodes equals 1. Oh, we need to give it a name, of course. We'll call it GDB for its HPC example. So we're going for a single node run. We'll run only with 2 tasks on that node. So we've just got one process attempting to talk to process 0 only. And CPUs per task is 1. We're just going to place those 2 tasks next to each other. We aren't going to be doing any OpenMP or anything. Oops, sbatch. And let's set 20 minutes on this. I'd just like to be sure that when it's running, we have time to connect with GDB for HPC and poke around a little at what's happening. 10 minutes might just not be enough time. So we'll say that we've got a maximum time limit of this on this of 20 minutes. Then we've got to tell it how to run. We've got to pass the tell it which nodes to run on. So we'll do sbatch partition, and we're just going to run on the standard nodes, not a high memory node. We're not running on the serial partition either, just a normal standard compute node. QoS. So remember, we could go for short if we wanted. Everyone can run on short, and this would be fine. 20 minutes is the maximum time that a short job can run for. We'll still keep it going on our reservation though. So I'll say QoS is reservation and sbatch reservation. And I need to tell it which reservation, and I'll grab that from the Etherpad document. like so. So now it knows that it's going to run on our reservation. Something I didn't say, so the reservations are, I think, always locked down to the specific group of people to use them. So this reservation was created for us on this course, so only those of us using TA051 accounts can actually use this reservation. Other people could put this in their job scripts, but they would find that that Slurm wouldn't allow it to enter the queue. It would give you an error message at the point when you tried to send it in. Okay, let's just add these last couple of options. We're just going to do sbatch hint no multi-thread. This doesn't really matter for this one, but I'll add them anyway. We're only running with 2 tasks, so it's doesn't really matter where we place the processes on the cores, but I'll add them anyway, just for completeness, I guess. Okay, then we don't need to module load anything because we are just we're just using the executable which we built in this directory. So we can skip that. I will still do export OMP num threads equals 1 to make sure that nothing in libsci or the like starts trying to use threads. We're going to turn that off. Finally, we just do our srun itself. So we say srun, and I've forgotten what I called it already. GDB for HPC exercise. So let's go back to editing it. It's just GDB for HPC underscore exercise. Okay, underscore exercise. Yeah, we did talk a little about this yesterday, Andy, about the run paths. Of course, if anyone has any questions about them now, it's a fantastic time to ask them. It is magic. Yeah, so if anyone wants to ask questions about the run paths, which we talked about, remember yesterday in the development environment session, please shout out now. It's your chance. But I'll carry on just for now, in case. No. Okay, great. Okay, so something else which is different, just to make sure everyone's on the right page here. XTHI in the example on the left is being module loaded here, so it's adding the location of the binary into the path environment variable. So that means you can just do XTHI, and it will know where to check, and it will find out where XTHI is and run it. The location of GDB for HPC exercise is not in the path, so we need to tell S1 here where to XTHI waves. Is it? XTHI. Hello world. Ah, got it. Okay, so yeah, so but for GDB for HPC, we need to tell it where it is. Just in the same way, if you were to run an executable normally, you would, which you've built yourself, you would do GDB for HPC exercise. You know, the way you're probably always doing /a.out. So we've got to have that little / in there to say run GDB for HPC exercise. It's located in this directory. So that should now run, unless I've forgotten something silly. Let's give it a go. So it's been submitted. So apparently I didn't forget anything obvious. Let's see how it's doing. Remember, this is the all-important command that actually sends the job off to be run on the compute nodes. Something's happened. Of course. Fatal error, invalid rank, error step. Invalid rank has value 1. Okay, so it's quitting before I can get in. What state is the code in now? Let's take a quick look at gdb_exercise.c. What's it doing? And at this point, it is. Did I launch it with 2 processors? Ah, that's why it's crashing. That's silly of me. That should have been 2. So it's quitting at this point because it's trying to do something daft like send to task -1 or something, and of course it can't because there is only 1 task. So if I just make that 2, now it's at the point when they're going to be it'll be sending to the wrong task with the wrong tag, and it'll crash. Well, it won't crash. It'll be waiting forever on that MPI receive because the right message will never arrive. Let me just delete that slurm there. Let's just keep the directory clear. Okay, so that was a mistake on my part. Let's sbatch the script again. Sbatch run.slurm. And now I'll check again with SQ to see the status of my job. And that's running. It's been going for 7 seconds. It's on this same code, which we've seen again and again the past couple of days. Okay, so that seems to be stuck, given it's doing no work at all. It's just hanging. If we check the slurm output file, which remember just merges the standard out and standard error together, it's empty. So that does seem to be hanging. Okay, great. So the process for what we're going to do now, attaching to a running job, isn't in what we've got here. So we'll be following the process from the documentation. So I guess here's another guide, how to use the documentation. So the documentation you can just get to from the ARCHER2 website. And that's just docs.archer2.ac.uk. We want to know about how to debug. So that's in the user and best practice guide. Let's go there. And debugging is down here. And here's a section on GDB for HPC. We've already been doing this, how to launch through GDB for HPC. We're going to try this now, attaching with GDB for HPC. So this is showing how to launch a job through a single S-run line. We don't need to worry about that because we've already launched our job, and we can see it's still running. It's been spending 1 minute 52 seconds now doing nothing at all. Obviously, it's not in a good place. We need to help it out a little. So let's follow this. So we need to find out the process ID here and the job step that we want. So we need to use the stat command to do this. So first of all, we want the job ID. We were told it when we did sbatch run.slurm when we sent our job off to run, but we can find it again at any point with SQ. And here's our job ID. Let me stop that wrapping so badly. Job ID is 1037582. So if we wanted, this would be how we would cancel it. We would do 1037582. That would be how we would cancel the job. We're not going to do that just now. We're going to find out some more about the job by running the stat command in it. This isn't the command which we looked at yesterday. It gives us a lot more information, so much that it's a little hard to read here because we've again got this horrible wrapping. Maybe if I put it through to less, we did see this yesterday, remember? If you do less -s, it puts it all on a single line, and when we've got these long tables with many columns, this makes it much easier to scroll through. And what we want to know is the job ID, and this bit on the end, the step number. So we've got step 0. So this is the important bit of information that we want. It's 103.7582.0, and that is what's hanging. So now we can try to attach to it with GDB for HPC. So remember, we haven't done anything to the modules in this state. We've just got the same modules we had when we logged in. What we don't have yet is GDB for HPC. So let's load GDB for HPC, like so. Remember, there's the ML command we could also be using if we wanted to shorten the number of key presses. And that will show us now that we have GDB for HPC loaded and ready to use. So we can start it up, GDB for HPC. And we have a similar command to, well, we can see some similar symbols here, I'll say, to what we were doing this morning when we were launching from GDB for HPC. We've got to use this $ symbol again to provide a reference to this job within GDB for HPC. So let's attach now is our command, and we'll call it let's call it GDB exercise. I'll call it GDB prog. We can call it, remember, anything we like. What we don't have to do is now tell it how many tasks to launch, because that's already happened. It's there running on the system. We're just telling it to attach. Then we provide that job ID and the job step, so 103.7582.0. And now we'll try to attach. That seems to be going through. Have to wait a second. And here we go. And this looks like it's giving us a backtrace. Yes, so it's told us, it's given us the current backtrace of what's going on. So at this point, we're attached. We can start to debug with GDB for HPC. We can start to try and work out what's going on. And this is showing us that, well, we can actually see right away what the issue is. Let's try, well, we can see that they're both in main. However, process 0 is waiting at an PMPI barrier, and this is waiting at an MP, and process 1, task 1 is waiting at an MPI receive. Remember, that was the problem. The MPI receive isn't correct. It's blocking. So process 1 is going to wait there forever until a message which was never sent will arrive. That's the first problem to fix. We should also be able, I think, to do a list. And okay, so it doesn't give us that much information. So it's mainly the backtrace, I think. I think probably most of the time you would be doing this, you would be finding that your program has reached a point like this, and you would be looking for the backtrace to find out where it is. Okay, Mike says, thank you so much. My code would take too long to build, so I'll attempt to. And you have to run now. Okay, that's, you're very welcome, Mike. I'm really happy it's been able to help you get going. And as I say, if you do run into issues, the documentation's there. It's, I think, pretty helpful, pretty complete. So that would be a fantastic place to just check through, see if there's anything useful for what you're dealing with. And if you have any questions or problems, please get in touch with the service desk, and we'll be really happy to help you out. Okay, great. Yes, so the link to the material here will be available, should be linked to at the moment, I hope, on the website. And if it isn't, it will be. I'll make sure of that. And recordings of this will also be made available. They should be going on YouTube, I would guess, in the next few days, and they'll also be linked on the ARCHER2 website. So if you just go through well, let's just go now. It will be there. Yes, as long as GitHub pages and YouTube are available. Yes, so it should be here in the training materials repository. So if you click on training, then training material repository, well, you can see all the past ones are here, including past runs of this course. So you can just find it, click on it, and you'll find the links there. Okay, so at that point, what we can do is we can release. So we could go on and debug this however is appropriate. We already know how to solve this. There's an MPI receive waiting, and that's never going to move on because it's blocking, and the message was never sent. Message that it wants was never sent. Process 0 is waiting at a barrier. Of course, that will never happen because process 1 is waiting earlier on for its receive to happen. So both processes are just stuck waiting. So we know how to do that. What we would do is we would then, whenever you're done, you can then release your reference to the program, to the job. So we would release gdb prog to let it go. That's now just running in the wild again, I guess. We can exit that, quit it rather. And if we sq -u WLTA051, again, the job is still running. So we did go slightly over 10 minutes. So you can cancel that. Now it's completing again. That's a good question, actually. I don't believe you do need to. Actually, no. I think what would happen, I think it releases automatically any which you're still attached to at that point. I would say let's find out, but well, let's just find out. We may as well, since we're there. Let's just quickly attach to my prog. I'll just call it this time so you can see it works with whatever. And it's 0.0, isn't it? Oh, of course. Did I start it up again? Oh, there's some more. Okay, so I need to sbatch. Okay, so we want to do stat on this, and we'll find out it's that. So if I do gdb for HPC, let's just confirm. If I do attach to my prog on that, it will attach to it, give us a backtrace, and I'm nearly certain, because there wouldn't be any reason for it to have the GDB servers running. If we quit, it will, yes, it releases automatically. So at this point, the job is just running as normal again. Well, it's still stuck, but it's trying to run. So we can just cancel it. If it had run correctly, you would just leave it to go, and then at some point you would find a slurm.out file. The number here would be the job ID, so you could take a look at that, and well, there won't be anything in here because there's, well, there is, it just tells us that we cancelled it, but there's no output from the job itself. Unless, of course, in your slurm file, you told it, in your slurm job script, you if you were to tell it to put the standard out and standard error into different files, you can do that. But if you don't, you'll just have this file. at that point, you can just log out, or you can take a look at the output files you're getting, but it can just be a matter of doing exit, and that's you done. Okay, so I hope that was a decent run through of going from login to getting some code, building it, writing a job script for it, submitting it, trying to attach to it while it's running with GDB for HPC, cancelling it, and then logging out. So I mean, of course, what you actually do while logged in is going to be 100% dependent on what you need to do while you're logged in. But those are sort of the general steps. Log in, get your environment set up, do work, log out. And I can see Andy's helping you, Monica. Yeah. So basically, yeah, as Andy's saying, unless your application is really simple and just uses the sort of bare bones system libraries, you'll need to rebuild, and definitely if you use MPI. Okay, so I don't recall if there were any other questions or the like. Does anyone have any questions about what I've just been showing there? Oh, you're very welcome, Angelas. As I said, I think GDB for HPC is actually really handy. It saved me quite early on in my use on ARCHER2 when I was trying to build an application. This was very early on, and it was seg faulting, and nothing was giving me any reason as to why. But I was able to use GDB for HPC, and it absolutely saved my bacon there. Told me it was that the application was trying to open a file which doesn't exist on ARCHER2. So yeah, it can be very handy. Okay, so how are people feeling then about the optional tasks here? The bootstrapping tasks. How does anyone have any code they would like to have a go with on ARCHER2, or are people looking at trying to benchmark runs with GROMACS? You'll be okay. Well, okay, great. Well, as I say, I hope that's been helpful. Please do get in touch with the service desk if you run into any problems, and we'll be happy to give you a hand with them. Great. Okay, thanks. Take care then, Angelos. Take care. Yeah, Monica, there is a lot, isn't there? Um, if I would say whatever you're doing, try and start simple, and in particular, remember the points. I think is actually a really good point from this morning. Was it this morning? I think it was being a good citizen. Yeah, test before saying. I would say definitely before you run anything big and complicated, try running smaller, simpler things, make sure everything's working, because you'll probably get far fewer headaches that way, and there's much less chance of accidentally losing all your resources. So yeah, just keep things simple, build up to the point where you want to get to. Yeah, I hope that been at least a good start to using ARCHER2 for you. And Ruth says, I was thinking of trying to compile bicycles, might take some time. Well, if you would like to give it a go now, I'm planning on sticking around until either 4 o'clock when this session is meant to end, or until the last person leaves. So if you would like to give it a go now, Ruth, please go ahead. If you do think it would just take too much time, otherwise, as I say, yeah, you can absolutely have a go yourself, see how it goes using the skills you've learned in this course. And if you do run into issues, help is always on hand if you need it. And Monica says, yes, that's the usual. Well, yeah, it is, isn't it? I think ARCHER2, because it is an HP Cray machine, it has, in particular, I think the programming environment can be a little unusual for people sometimes when they first get logged on, if they aren't used to Cray systems, because there are the compiler wrappers and the like, and the programming environments which they have to remember to use. So that can sometimes trip people up when they're first starting to build their software, because they might just use G-Fortran because that's what everyone always uses. But I think once that time's spent, once that time is spent getting the initial learning process done, the initial ramp out of the way, with the initial learning curve, I think it actually works out really well. Our account for this tutorial, it's not valid. I think it's 30 days. Perhaps Andy knows. I think there are 30 more days.
Yeah, it's typically 3 to 4 weeks after the course ends. You've got access to try out stuff. And usually, what we say is, we do that because we want people to be able to. You don't think of all the questions. You want to carry on trying things out. You don't get a chance to do that on the course. So having the access for longer is fine. If you do have any questions during that time, something comes up that you don't know the answer to, or that you want to ask, then just drop a line into the service desk, mention you're on this course, and they'll route it in the right direction to get your questions answered.
Yeah, something. Yeah, absolutely. Yep, you can carry on. The reservation that we've been using, as I said, it will run out at 4 o'clock this afternoon. So if you do log into this account to carry on trying things out after 4 o'clock this afternoon, you'll have to just send jobs into the regular QoS at that point. But yeah, as long as you have access to this course, to this project and the account, you can go ahead and do that. Yeah, and absolutely, you should absolutely go ahead, try things out. Learning by doing is absolutely the best way to do it. I could sit here and talk at you for a whole week, but probably it's the actual, just using that to get you going is absolutely the best way to learn, and really, really get that knowledge ingrained in your mind. Okay, great. And Ruth is just downloading the code. Yeah, absolutely, fantastic. So yeah, let's absolutely have a go with it. See how it see what happens. I'm going to look this code up. Actually, it's not one I think I've heard of before. Ah, it's an AMR. It's an AMR ice sheet modeling effort. Oh, actually, I think I have heard of this. I think I had an HPC Europa visitor doing something with it. I can understand that, Monica, absolutely. Okay, so I'm just looking at bicycles at the moment. At Ruth. Oh, okay, so I'm working on a version of the Met Office here which has bicycles coupled to Nemo. Also, a few layers of complexity here. Yes, so I mean, yeah, I'm looking at bicycles. I guess this is probably for a standalone build. I'm just on their website, and this is sometimes worth doing. Sometimes what's worth doing is seeing if they have any site-specific instructions which can help you get started. So bicycles, at least, they have build steps for NERSC, which is a Cray XC40, I think. Where is it? It said somewhere. Oh yeah, yes. And so they go through some steps, so you can kind of see maybe what they have to do on their own Cray system to build it. So they describe they're using plugin of GNU. They have to load Cray HDF5 parallel. They use netcdf HDF5 parallel. It may not be the same in particular because ARCHER2 is one of the newer Cray systems out there, and it has a lot of newer piece of system software which may not map directly to what's on the older systems. But although there are some differences, it may be a good starting point. Yep, and as Andy says, NCAS look after the on ARCHER2, so they have their own service / help desk, may be able to provide assistance.